Okay, so we're on question 13 now, and at this point the questions are getting pretty tough. So we're just going to do our best here to get through it, but don't be that upset if the questions seem really difficult once you get to the end here. This is the end of the multiple choice, by the way. The difficulty resets on the short answer section, which we're about to get to. So looking at 13, if x is greater than 3, what's equivalent to 1 over x plus 2 plus 1 over x plus 3. Okay, so that's a messy expression. And we have fractions on the denominator. Now you should never have that. So we're going to have to somehow simplify that. But this is a very difficult simplification problem. First things first, however, we see that the thing to the left here and then we have a thing to the right. We can put those together. That should be our first step. So 1 over x plus 2 plus 1 over x plus 3. So how are we actually going to put these together? Well, they need to have the same denominator. So in order to get the same denominator, we can do x plus 3 over x plus 2 times x plus 3 plus x plus 2 over x plus 2 times x plus 3. So what I've done here is I have multiplied the left term by x plus 3 over x plus 3 and the right term by x plus 2 over x plus 2. And the reason I could do that is this will actually cancel out, so it's really the same as multiplying by 1, so we haven't actually changed the value of this, so it's not an illegal operation. But this way we have the same denominators for both sides. So now that we've done that, we can put these together, because these are fractions with the same denominators. So we have x plus 3 plus x plus 2 over x plus 2 times x plus 3. Simplify a little bit, I suppose. We'll get 2x plus 5 over x plus 2 times x plus 3. Parentheses. Okay, so that's what's going to be on the bottom. So that's what this bottom part is. So now we have 1 divided by 2x plus 5 divided by x plus 2 times x plus 3. And all I did here was I plugged this back in to the denominator of this term, since we just took the bottom part out to start with. So this is what we're actually interested in evaluating. And this tends to confuse students a lot too, because we have an apparent fraction over a fraction. And a way to understand this is something like, let's actually try this out. An easier example, so let's say we have 1 divided by 1 divided by 2, or 1 divided by a half. So thinking about that, we have 1, how many sizes of 1/2 can 1 be split into? Well, the answer would be 2. So if you had something of length 1 tall, and you split it into lengths of a half, how many lengths would you have? You'd have 2 of them. So, but what basically happened here is the denominator of the denominator came up to the numerator part. So if you had something like a divided by b divided by c, this is the equivalent of a times c over b. So you can take this c up top. If that's clear. But if not, we can also rewrite this as a divided by b divided by c. So we just kind of rewrote the division sign in this way. And then dividing by a fraction is the same as multiplying by its reciprocal times c over b. So you'd get that. And this is also ac over b, which is what I said it would be. So that seems to have worked out. So applying this to this situation now, I know that you just take this part, put it up top. So I'm going to end up with x plus 2 times x plus 3 divided by 2x plus 5. So sorry I couldn't really simplify this to an even more basic level, but this is just an advanced simplification problem. This is just something that comes with practice for the most part. So this is going to come to, well, it's not d or c because they don't have numerator and denominator. This is the inverse of this. This is like flipped, so it's probably b. And if you multiplied these together using the FOIL method, you'd get this as the numerator. So let's just move on to 14 at this point. This is actually one of my favorite questions of all time. Extremely complicated, though, or confusing. If you don't remember, your exponential algebra. So let's just read this. If 3x minus y is equal to 12, so that's a linear equation, what is the value of 8 raised to the power x divided by 2 to the power y? Okay, so here you're really going to have to know your exponential algebra. If you don't remember it, that's okay. We're going to derive it from scratch right now. So the rules are, if you have cases like x to the power 2 times x to the power 5, so what would that be equal to? Well, let's actually write this out a little differently. X to the power 2 is just x times x, because that's what squaring a number literally means. And x to the power 5 is x, or 5x's, 3, 4, 5, so there's 5x's there. Doop, doop. That became that part, and then this becomes this part. So really we have 7x's being multiplied together, so this is x to the 7th. So this would be x to the 7th. So, but the general rule is going to be x to a times x to the b is equal to x to the a plus b. And you can see that here we had 2, 5, 2 plus 5 is 7, which is what you would get here. And so x to the a, x to the b is equal to x to the a plus b. Okay, so that's the first primary rule of exponential algebra. So you might recognize that, actually. This is probably late math 2 or sophomore or junior level algebra, something like that. Another rule is if you have x to some power to some other power, like this. So let's actually do an example of that. So let's say a is 2 and b is 3 in this case. So x squared, you can rewrite that as x times x, and then that's raised to the power 3 still. So that means that we have 3 of x times x. So we really have this, which is really just 6x's being multiplied together. So that's really x to the 6th. So this whole thing becomes x to the 6th. And the way that we did that is we have 3 groupings of pairs of x's. So this was really a multiplication operation that happened here. And indeed here you can see that it's 2 times 3 is equal to 6. So x to the a to the b is equal to x to the 6th. Oh, I'm sorry. It's equal to x. Let me just rewrite this down here. X to the a to the b is equal to x to the ab. So like that. That's another fundamental rule of exponentials. And then a third, there's actually like 2 more that I like to remember, but we only need 1 more of them, so I'm only going to cover that one. And so the third rule is going to be x to the minus a is equal to 1 over x to the a. So all that's saying is if you have a negative exponent, you can push it across the division sign, and then it becomes a positive exponent. So in this case, this was just on its own, or this could be like divided by 1 or something. So it flipped, but then the exponential became negative. And a way to convince you of that would be if you had like x to the first power times x to the minus first power. We know from the first rule that this should come out to x to the 0th power, which is really 1. And so that means that x times x to the negative 1 is equal to 1, which means that what is it that we do? Okay, and so how do we undo the value of x to get 1? Well, x inverse must be equal to 1 over x in order for that to be true. So that's just a quick example where in this case a is 1 and it just came on to the bottom part. So x to the minus a is equal to 1 over x to the a. So those are kind of the 3 big rules with exponential algebra that I like to remember. And now we can go back to our problem. So 14. So the reason that we're doing exponential algebra is because there's a lot of exponents here. We're probably going to end up using it. So I notice firstly that these are not the same bases. We have an 8 and we have a 2. But I know that 8 is a cube of 2. So 8 is equal, what I mean by that is 8 is equal to 2 to the 3rd power. So 8 is just one of those special numbers that you should recognize immediately. So like the cubes up to 5, so 1, 8, 27, 64, and 125. If you ever see those numbers, that's indicative of this is a cube, and if you have a cube root, that's probably coming up. as well as some of the squares. You should probably be able to identify those. So anyway, let's rewrite this now as, so we have 8 to the x over 2 to the y, but 8 to the 8 is 2 to the third to the x, so I just replaced 8 with 2 to the third over 2 to the y, and now at least they're the same basis, so I'm kind of happy about that. This is one of our rules. This is this rule, so we multiply those together. So we have 2 to the 3x divided by 2 to the y, and then this is on the denominator. I'd like to bring it up top, but in order to flip it from numerator to the denominator or vice versa, I have to negate the exponent. So this is really equal to 2 to the 3x times 2 to the negative y. Okay, and now I have the exponents being multiplied together, and when they're multiplied together, I add the exponents. So at this point, this is equal to 2 to the 3x minus y. Okay, and now if I knew what 3x minus y is, I'd be able to finish up this problem. On the bright side, I know what 3x minus y is. 3x minus y is 12. So they literally just gave that to us in the problem. 3x minus y is 12. So this is really 12. 2 to the 12th power. It might not have seemed obvious why they included this initially, but that's how it came in. So it's answer choice A. Very difficult problem, but very fun once you get the hang of it. So now, last one I'm going to show in this video is 15, and this is the last of the multiple choice section. So let's just finish this up now. Okay, I have an expression on the left side is equal to something on the right side. These are in different formats. For all values of x, and also a plus b is equal to 8. Not sure how that's going to be useful right now. What are the two possible values for c? Alright, so just looking at this, I notice immediately I want to multiply these together, and we have to do the FOIL method since these are being in parentheses. To explain that a little bit, we might imagine it the Greek way. So ax might be the length here, and then plus 2. So that might be the length here. So this whole length of this side is ax plus 2. And so that's this expression here. And then we have bx. So let's call this length bx. And then 7. So let's call this 7. And so this whole side is bx plus 7 in length. The reason I said this is the Greek way of doing it is the Greeks interpreted everything geometrically. So multiplication, if you remember, the area of a rectangle is the length times the width, which is just a multiplication operation. So we can actually express multiplication in terms of a length and a width of a rectangle, like we're doing here. So this is our rectangle. We'll split this up. This is kind of a bit of a proof to explain why the FOIL method works. And the area of this rectangle, ax bx, is going to be abx squared. The area of this rectangle is going to be ax times 7, so that's 7ax. The area of this rectangle is 2bx. And then the area of this little rectangle is 2 times 7, so that is 14. And so the area of the total rectangle, which is equivalent to the product of these two things, is going to be abx squared plus 7ax plus 2bx plus 14. That's exactly what you would get if you applied the FOIL method as well. Where you do ax times bx would be abx squared. That would give you your first term. And then you'd get all the other terms from the rest of the multiplications. This is just another way of expressing that. These both have x's. I'm going to simplify a little bit. So abx squared plus, this would be 7a plus 2bx plus 14. So that's the left-hand side. And then this is the right-hand side. And now I have to kind of figure out what I'm going to do here. I know that a times b must be equal to 15 because they are the x squared terms. So the coefficients must be equal to each other. So let's actually write that down. A times b is equal to 15. So that's a big deal. And then we know, well, the c terms line up, as they should, because there's no other way to make or add 1s to either side. And then cx, so c would be equal to this coefficient. So c is equal to 7a plus 2b. Let me rewrite this out a little bit just to make sure I was clear on that. So we already simplified the left-hand side. We found it to be abx squared plus 7a plus 2bx plus 14, and that's equal to the right-hand side, which was 15x squared plus cx plus 14. And we can see here on the left and right, well, we can get rid of the 14s pretty quickly, but there's something times x, and here is something times x. There's no way that anything times x squared will give you an x value, so this must be equal to c, and then this must be equal to 15, because this is the x squared part of it. So that's how I got those simpler equations out of it. So coming back here, I know that, and then I know that, and then they also told me that a plus b is equal to 8. So knowing this and this, well, first off, a times b is 15, so let's have some initial guesses here. A logical one would be a is 15, b is 1, something like that. You can also have 3 and then b is 5, something like that. Or the opposite, where b is 5, where a is 5, and then b is 3. In this case, they have to sum to 8, so I'm kind of limited to these two possibilities. So, yeah, 3 times 5 is 15, so it satisfies that. And then 3 plus 5 is 8, so it satisfies that as well. And then the reverse also satisfies both of those. So there's actually two possibilities for A and B. So C, let's take the first possibility first. 7 times A is 3 in this case, plus 2 times B, which is 5 in this case, and then we can just do that arithmetically. That's pretty easy. So that's 21 plus 10, so that's 31. And then I'm going to call that C1. That's our first value. C2, which will be where the values are reversed in this case, we're going to have 7 times 5 plus 2 times B, which is 3 in this case. So you can see the A and B's flipped. And then 7 times 5 is 35, plus 6 is going to give me 41. So I got 31 and 41, and then I pray to God that's one of my answer choices. Okay, that is one of my answer choices, so it looks like that worked out pretty well. So again, answer choice D for that. Although that one was kind of tough. It was kind of fun along the way too. It wasn't anything that crazy really, but yeah, that's how you do all of those. And now we get to go into the next section.